Hello everyone, today I'm going to be talking about nodal analysis. I'll talk about what it is, what it's used for, and then go through some worked examples. So what is nodal analysis? It's a powerful analysis tool for finding out unknown voltages using Kirchhoff's current law. First of all, you need to know what a node is. A node is where two or more branches are connected in the electrical circuit. So as you can see here, B is a node because two or more branches are connected, and C is also a node. When performing nodal analysis, it is important for us to first identify the directions of the currents in each branch. So as you can see, it's already been identified in this diagram. However, I'm going to make them a little bit clearer. So I1 is going to the right, I2 will be going to the left, and I3 will be coming straight down. This is important when forming your equations. In our case, our unknown node is the node in the middle, VB. This will be the node at the center of the analysis. Now we can apply Kirchhoff's current law to our node. So Kirchhoff's current law states that the sum of all the currents going in to the node are equal to the sum of the currents coming out of the node. So what do we have here? We have I1 plus I2 are coming into the node, and they are equal to I3, which is leaving the node. Now we need to identify the voltages which we already know. So down here we can take as the ground, which means that our voltage in the reference node will be 0 volts. In this node, VA, we know that it is 10 volts greater than the reference node, hence VA will be 10 volts. The node VC will be 20 volts larger than the reference node, hence it will be 20 volts here. Now we can start writing equations for our currents in terms of the voltages. I1 will be the voltage from 10 volts minus VB, the unknown, all over the resistance, which is 10. I2 will be the voltage from, which is 20 volts, minus the unknown, VB, all over the resistance, 20. And they will equal to I3, which will be from VB, minus 0, the reference node, over 40. Now you simply solve the equation for VB in order to find its voltage. For this particular example, you will get that VB is equal to 80 over 7 volts.